Hello folks, a question that you might ask yourself is, why should I invest my time on the course Learning Shell Scripting in Linux C Shell Environment? It's not true that only Bash Shell or its scripting is used at organizations worldwide. C Shell has several advantages over Bash Shell. It is actually easier to learn. Do you want to learn Python, Ruby and C in the future? Then this course is for you. I have provided my book Learning C Shell Scripting Gently with this course. You need to watch the video and read the book. Only then you would have truly learned C Shell scripting. The book has several topics that will be helpful to system administrators, newbies, and of course those who want to learn scripting. I would go on to say that you should first learn C Shell scripting and then go about doing Bash, Python, Ruby, or C language. Some concepts, such as functions in Bash, may take a while to learn. You may have read that C Shell has many faults, but why should engineering firms use it? Because engineering firms rely on scientific precision. I have also provided my book on basic Linux. I hope you enjoyed the journey. You will assuredly learn a lot by watching the video and going through the books. Just look at the course matter. The course has more than 50 questions as well. Best of luck. Thank you. Hello folks. Welcome to the course overview of learning shell scripting in Linux C Shell environment. The endeavor of this course is to cover the nitty-gritty of C Shell environment before putting your attention into creating scripts in the C Shell. All the components needed to fire your shell scripts are covered. In this section, you learn about history of the C Shell or CSH, what is a shell, installation of CSH, creating an user defaulting to CSH. History of C Shell. Bill Joy developed the C Shell at the University of California, Berkeley. He is also famous for founding the company called Sun Microsystems, eventually bought by Oracle. You can find many resources on Bash scripting, but scarcely anything on C Shell scripting. This course is an attempt to fill this gap. While Bash scripting is no doubt popular and widely used in many a vertical, C Shell scripting has created a niche of its own. It is the de facto shell in engineering companies. It is also used in universities due to its resemblance to the programming language C. In my opinion, it's the skill that you ought to have in your CV for the differential it creates. It can also be a precursor to learning the C language and then proceed to popular languages such as Java, JavaScript, and Python. Prerequisites for this course. You must have some knowledge of any Linux operating system. If you do not have the requisite experience, please go for a basic learning course on Linux. I have included my book, Linux, a Quick Learning Guide here. You may like to read this book. Infrastructure. I have used VM VirtualBox on Windows 10 machine with Ubuntu and CentOS installation. I am accessing Ubuntu and CentOS using PuTTY from my Windows 10 desktop. What is a shell? A shell is an interface between you, the user, and the system. This is a simplistic definition of a shell. It is a command interpreter as well. The shell translates the command you enter in the shell to a language understandable to the system. Here, the system refers to the kernel. The kernel is the heart of the Linux operating system. In fact, the kernel is the Linux operating system itself. So the shell coordinates with the kernel to get the commands you enter to be executed. The kernel itself provides an abstraction layer between you, the user, and the hardware components of your computer through drivers. This relation is illustrated in the following screenshot. The shell also offers programming abilities. If you're coming from the Windows background, you will understand the role of CMD or command interpreter and DOS batch programming. Similarly, the equivalent of DOS batch programming is shell programming in Linux distributions. The shell script is nothing but an ASCII or text file that has a series of control or decision structures along with commands that you use on the command line. The three main shells are bash, corn, and C shell. Obviously, the bash or born again shell and corn shells are very popular worldwide, while C shell has a niche market in mostly engineering firms. Finding out your shell. To find the shell you're using, log into a Linux distribution of your choice. Enter your credentials, that is your login name and the password, and you will see the prompt, the $sign. To check if the shell is CSH, enter the following command on the prompt. The echo command displays the value of the variable shell. The shell is a pre-configured variable. Since it is a variable, $sign must precede it. So you enter echo space $shell. The value we get is /bin/bash. This is not what you are looking for. You want to see the absolute path to the C shell executable, which will be /bin/csh. Since you do not have the C shell, you must install it. Installation of CSH shell. To install the CSH shell, enter the following command. Logging to existing shell bash or ksh, sudo apt install csh. Note, this command is for the Ubuntu operating system. In CentOS, the command to install the C shell is yum install csh. You must also log in as root. Creating an user defaulting to C shell. After the installation of the C shell, create a user using the following command user add. You should use sudo from your current shell to elevate and use the user add command. The command will be sudo user add -d, specify the home directory, space -s, specify the default shell, in this case CSH, space the username, in this case Jeff. Thank you, and let's go over for a demo. In this demo, we will learn to check the value of the shell variable, install the C shell program on CentOS, create a user defaulting to the C shell. To check the value of the shell variable, enter echo space $shell. The output is bin/bash. So we find that we are in the bash shell, and it is time to install C shell using the command yum install csh. You have to have root permission. Since CSH is already installed, we can go ahead and create a user defaulting to the C shell. Clear the screen. -d to specify the home directory. -s to specify the shell and the name of the user. And we are done. Thank you. Hello folks, welcome to the quiz. Question 1. Which variable would you see to find your shell? Your options are A. Shell, B. SKEL, C. etc directory, D. dev directory. Question 2. Which command would you use to check the value of a variable? Echo in capital, echo in small letters, less command, more command. Question 3. Which command to add a user to your system? User, add in user, add user, user adding. You can pause the video to think. And here are your answers. Thank you. Hello folks, welcome to the section Fundamentals of Shell. In this section, you learn about Introduction to Streams, Redirection, Introduction to Variables. What are streams? Linux Unix operating systems offer three kinds of streams. Streams are channels of communication between the input command that you type from the keyboard and its resulting outputs that you see on your display monitor. The outputs are of two types, standard and error outputs. The operating system assigns each stream a file descriptor that you see in the following table. Note: a file descriptor is a handle or a number that is assigned by the operating system. As we see, there are three kinds of streams: standard input, standard output, standard error. The file descriptor associated with standard input is 0, with standard output it is 1, and with standard error it is 2. While the symbol for standard input is less than sign, for standard output is greater than sign, and for standard error it is 2 and greater than sign. The device associated with standard input is the keyboard. The device associated with the standard output is a monitor or a file, and the device associated with the standard error is also the monitor or a file. Redirection. This topic is associated with streams. Redirection allows you to change the standard pre-assigned device associated with standard input and standard output. For example, you can redirect the content of a file in standard input stream to a command, or instead of displaying standard output on your monitor, you can redirect the output of a command to a file. For instance, who, which is a Linux command to show you the number of users logged in your system, its output can be redirected to a file called userlist.txt or any file name of your choice. You can also redirect standard input to a command. This is best illustrated by using the Linux's sort command. Consider this file containing the results of a class test. You see Jerry has got 40, Mary 78, Peter 89, and so on. If you redirect the content of this file called class test as an input stream to sort, the command will sort the result in the alphabetical order. As you see, the content of the file class test has been fed as an input to the sort command, and sort has sorted the results in the alphabetical order, as you see Anne, Bob, Earl, Jeff, Jerry. A pictorial representation of standard input and output stream of this example is as follows. As you can see, this is the standard input, which has the content of the file called class dead has been fed to the sort command, the Linux command, and the output that you see is actually the alphabetically sorted content of the class test file. We are still in the redirection topic. Please note that while standard error is supported in the bash shell, it is not supported in the C shell. Using the standard error symbol in the C shell, 2 greater than sign results in an error. So if you're using it here on the C shell, you will get this kind of errors. Let's move over to the next topic, variables. A variable is a location in the memory of your system that stores or holds values. There are two parts of a variable, its name and its value. There are two kinds of variables: user and system or predefined variables. The user variables are defined by you. Here we are trying to define a variable in the bash shell that is applicable to the current shell using the set command. This set command accepts spaces between the assignment operator equal to. So we are setting the variable called hi to a value called hello. And to check the value of the variable hi, we use the echo command. What does it mean that it only applies to the current shell? Let's try the same example on the C shell. So we define a variable called hi, assign it a value called hello. We check the value of the hi variable using the echo command and we get the hello value. To open another shell, we just type csh, which means that it opens a child shell. And then when we check the value of the hi variable, we see that we get an undefined variable message. So you can infer that the variable hi is not inherited when another instance of the C shell is opened. Thus, it is called a local variable. If you want to have another instance of the shell inherit the value of a variable, then you should define the variable using the setenv command. This is applicable only for the C shell. That variable is then called an environmental global variable. Unlike set command, setenv does not use the equal to operator to assign a value. A space will do. For example, here you define a variable, an environmental variable called hey, and you assign it a value called hello, and then you check the value of the hey variable and you see that you get an output hello. Then let us open another child shell using the csh command. As you can see, the child shell has inherited the value of from the parent shell. Welcome to the demo. In this demo, we learn to redirect the output of a Linux command to a file, and then understand the difference between a shell variable and an environment variable. Run the who command. The output that you see on the screen can be redirected by using the greater than symbol. Open userlist.txt with using cat command. You can see that the redirection is successful. Let us set a shell variable on the C shell using the set command. Let us check the value of the flower variable. Rose. Let us now open a child shell simply by typing csh. Let us see the value of the flower variable. It is undefined. A shell variable's value is never inherited in the child shell. Let us go back to the parent shell, clear the screen. Now we can set the environment variable using the setenv command. Check the value. Let us open a child shell and check if the value of the name variable has been inherited. It is inherited, so this is an example of an environment variable. Thank you. Hello folks, welcome to the quiz. Question 1. Which symbol creates a file? Your options are A plus, B equal to sign, C greater than sign, D, less than sign. Question number 2. The symbol of append is A, greater than, B, greater than 2 times, C, equal to 2 times. Question number 3. In the bash shell, which command will work? Your options are A, set space H space equal to space 100. The second option is set space H is equal to 100. Here are the answers. Thank you. Hello folks, welcome to the section The C Shell Essentials Part 1. In this section you learn about redirection of the error stream in the C shell and command combinations. The C shell does not support the standard error stream 2 greater than sign. Remember that 2 greater than sign is supported on the bash shell. Instead, errors are redirected on the C shell using greater than ampersand or greater ampersand sign. Performing ls-l on a non-existent file like nofile.txt, you have a resulting error message. This error message can be redirected on the C shell by using greater than ampersand symbol. For instance, in this example, you see that the error has been redirected to a file called error store.txt and you no longer see the error message. If you want to append more information to the same file, errorstore.txt, then you can use the greater than symbol twice, ampersand. We continue with redirection of the error stream and introduce a new command called T. The T command serves a dual purpose. It sends the standard output to the monitor and to a file as well. Now, let us learn about command combinations. The command combination uses semicolon to execute two Linux commands as shown in the example, where date and uptime commands are executed together. We continue with command combinations and learn about and or operators used both in bash and C shells. We start with the AND operator whose symbol is ampersand ampersand. The basic premise is that of the two commands, the first command has to be successful for the second command to run. We create a file called hello using touch command and do an ls-l on hello along with AND operator and see that both the commands execute successfully. However, doing ls-l on a non-existing file called hello1, you can see that the failure of the first command stops the conditional on the track and the second command uptime does not execute. The OR operator, whose symbol is two pipes, operates on the premise that the first command must fail for the second command to execute. Doing ls on hello1, which is not existing, makes possible for the second command, uptime, to run successfully. Thank you, and let us go over to the demo. Hello, welcome to the demo. First, let us see how C Shell handles standard error stream. Let us do ls-l on a non-existent file. You get an error message. To redirect the error, use greater than ampersand symbol in the following manner. You no longer see the error. Let us go to another topic, command combination. You can club commands using the semicolon. For example, let us clear the screen. Date, semicolon, uptime. Thank you. Hello, welcome to the second demo. Let us see how the AND operator works. In the AND operator, the first command must be successful for the second command to run. But let's make things interesting by making the first command to fail and then using the OR operator for the same code to work. Because in OR operator, the first command must fail for the second command to work. ls-l on nofile.txt, this file does not exist, using the AND operator, uptime. So uptime must fail because the first command is going to fail because there is no file called nofile.txt. Okay, uptime has not run. Let us now try the OR operator. Pipe, uptime. Uptime should run now. And it has run. Thank you. Hello folks, welcome to the quiz. Question 1. Which Linux Unix command sends output of two entities to a file and standard output? Your options are printf, ps3, the ps command, t command. Question number 2. Which symbol is used for command sequencing? Your options are equal to, greater than sign, semicolon, colon. Question number 3. The redirecting symbol in C shell is greater than ampersand. Is it true or false? Here are the answers. Thank you. Hello, welcome to the new section, the C Shell Essentials Part 2. In this section, you learn about single and double quotes and backslash, and also command substitution in C Shell. Starting with the topic single and double quotes and backslash. Single quotes are powerful as they maintain the sanctity of the string enclosed. They can prevent variable expansion effectively, while double quotes also remove the special meaning of meta characters. In some cases, the double quote allows variable expansion. This is because double quotes will eliminate the special meaning of some meta characters, but it allows variables to expand to their values. Let us start with the double quotes example. Set a variable called a to value 50. Remember, this is a shell variable. Now check the value of the variable a using the echo command. We see that the value is 50. Now perform a substitution in the following statement, which is enclosed in double quotes. The price of 1 pound of meat is $8. We see that the substitution is successful. We are still in the topic of single and double quotes. Look what happens when you use single quotes. The variable expansion of $A is not allowed. And here lies the difference between double and single quotes. The single quotes prevents all kinds of expansion, turning off the special meaning of even the variable $A. We are still in the topic of single and double quotes. Double quotes also honors the long white space. When you use the echo command without enclosing it in double quotes, the long white space is ignored. While when you use the double quotes, it preserves the long white space, as you can see in this example. Let us talk about backslash. When you try to use the echo command with meta characters such as greater than sign, question mark, star, the shell is confused and throws you messages such as missing name for redirect or echo no match. Use the backslash to turn off the special meaning of such meta characters. This is widely used in commands such as set and awk. Welcome to a new topic called command substitution in the C shell. Command substitution is where the Linux command's output is turned into a string. A string is an order of alphanumeric characters that can be manipulated by other commands so that they can be used in shell scripts to test true or false conditions and pattern matching. Let us first learn command substitution in the bash shell. The output of the ls command, which is hello1 and hello2, hello1 and hello2 are just files in your current directory, is given to a variable called greetings using a special construct called dollar bracket open bracket close. You just need to put the command ls inside the construct and check the value of greetings variable, which is now hello1 and hello2. When you try to use the same construct on the C shell, you get an error because the bash construct dollar bracket open bracket close is not supported on the C shell. For command substitution on the C shell, use backticks. And now let us go over to the demo. Hello, welcome to the first demo. In this demo, we will see the difference between single quotes and double quotes. Let us first set a variable. Set a is equal to 50. Let us check the value of the variable, echo $a. Let us see what happens if we use double quotes in a statement. Echo double quotes, the value of a is $a. Because you are using double quotes, the value of a will be expanded. As you can see, the value of a is 50, but when we use single quotes, the value of a is not expanded. As you can see, the value of a has not been expanded. That means that single quotes will turn anything into a string. Thank you. Hello folks, welcome to demo 2. In this demo, we'll learn about command substitution. In command substitution, the value of the Linux command, that is the output of the Linux command, is put as a value into a variable. Let's see how it takes place. Let's create two files using the touch command. Touch hello1, hello2. Let us check the output of the ls command. Now this output, hello1 and hello2, has to be put into the value of a variable. So let us create a variable, and using backticks, we put the value of the ls command into that variable. Set greet is equal to backtick ls backtick. So it seems it is successful. Let us check the value of the greet variable. Echo $greet. Okay, so it has been successful. Thank you. Hello again. Welcome to the demo. In this demo, we'll learn about escaping characters. Escaping characters is a concept where the backslash is used to turn off the special meanings of certain meta characters. Let us look at the greater than sign meta character without using the backslash. Echo greater than sign. Missing name for redirect, which means that the greater than sign has a special meaning for the shell. To escape it, to make it literal, we need to use the backslash. Echo slash greater than sign. You will see the result, greater than sign. This is how you escape characters in Linux. Thank you. Hello folks, welcome to the quiz. Question number 1. The output of echo question mark is, your options are echo no match, B question mark. Question number 2. Do double quotes honor the white space? Your options are false or true. Question number 3. The single quotes maintain the sanctity of the enclosed text. Is it true or false? Here are your answers. Hello and welcome to the new section C Shell Customization. Here you will learn about C Shell user customization. C Shell, like the Bash shell, uses startup files to customize their user's environment. This customization is of two types. One that is applicable to all users and another for a specific user. The former is called system-wide customization, while the latter is personal customization. The etc directory is the repository of the system-wide customization files, while a user's home directory is where their customization files reside. The system-wide customization files are csh.login and csh.chrc. The personal customization files for C Shell are .login, .chrc, and .logout. The .login and .chrc files are for personal customization. Both the files are read when you log into the shell, but when it is a non-logging shell, only .chrc is executed. The .chrc file is the environment file for customization, while the .login is the shell file for customization. Let us create .chrc and .login files in /home/ptest directory and add the following pieces of code. Echo, the hostname is hostname. This is a command which is in backticks and is added in .chrc file. And this following code, echo, hello, today's date is date. Date is also a command in backticks, is added in the .login file. This is an example of a logging shell. Login as Peter. Provide the password, and you see the following messages. The hostname is centers.localhost.local domain is a message from .chrc file, while hello, today's date is Friday, June 30th, 2017 is a message from .login file. This is an example of a non-logging shell. For that, you need to create two accounts, logging from one account, and then after you logged in, use the su command to log in as another user. Here, only .chrc file is executed. So in the real world situation, stick to .chrc file for user level customization. We continue with C Shell user customization. csh.login and csh.chrc are used for system-wide customization. Make changes in these files so that all users logging to this machine will have the same default settings. Let us perform a small exercise. Let's look at the default permissions of csh.login and csh.chrc. Both the files are owned by the root and belong to the same root group as well. The root user has read and write permissions on both csh.chrc and csh.login. Both files contain lot of default settings, paths and aliases. Create a variable in each file. Set-env, http_proxy is the name of the variable, 8080 at the rate 192.67.90.30 is the value of the http_proxy variable. Log in as any user on the system and check the value of the variable http_proxy. You see this value. Imagine the power of csh.chrc if you have a large number of users. Just making changes in csh.chrc impacts all the user. Thank you, and let us go over to the demo. Hello, welcome to the demo. In this demo, we are going to talk about csh.chrc file, which is a system-wide customization file. A scenario for you. You are a system administrator and have implemented a proxy server. If you set the variable http_proxy for all the users, then all the internet users have to pass through the proxy server to get connected to the internet. You are not going to go to each user and add this variable. What you do is edit csh.chrc file and add this variable and its value so that users logging to the server will have the http_proxy variable set when they log in again. To edit the csh.chrc file, you need to be a root user. csh.chrc file is located in the etc directory. Let us edit it. So many settings are there in the insert mode, and we add this variable. 8080 is the listening port. And 192.67.90.30 is the IP address of the proxy server. We save the file. Now, the expected behavior is that any user, when they log in again, will have this http_proxy variable set in their environment. Let's check that. So we are ready to log in. Let's check if the variable http_proxy is automatically set. Echo. Yes, it is. So we are successful. Thank you.
Hello folks, welcome to Demo 2. In this demo, we are going to talk about the .cshrc file. This file exists in the home directory of the user and is used to set personal settings for that particular user. We are going to edit the personal.cshrc file of Sujata, put a simple message and log in again to check if the message is visible. So let's open the .cshrc file in the home directory and add the message. Okay, we are in the home directory. Let's open the file. cshrc. Let us go to the insert mode. Echo. Hello. I'm your RC file. That should do. Let us save the file. And now it is time to log out and log in again, and we should see the message. Okay, let's do it. Okay, so let's log in as Sujata and see if that message is visible. Yes, it is. So that ends our demo here. Thank you.
Hello folks, welcome to the quiz. Question number 1. Which is a system-wide customization file? Your options are .logout, .chrc, .login, csh.chrc. Question number 2. Which is the most likely residing directory of personal customization files? Your options are A/dev, B/etc, C/home/Sujata, or D/ or the root directory. Question number 3. Which command displays hidden files? Your options are ls-l, ls-t, ls-s, or ls-a. Here are your answers. Thank you. Welcome to the topic Advanced Take on Shell Fundamentals Part 1. In this section, we discuss the following topics: environment variables, the path variable, and other variables. Environment variables. There's a quirkiness associated with environment variables in the C shell, the variables that determine and form your user environment. Variables in uppercase are deemed exportable and those in lowercase are not. But this is not strictly reinforced in real-life production scenarios. Some environment variables that you need to be aware of are: path variable contains the list of directories where executables is searched for by the shell. You should check the value of this variable along with the which command. The shell variable, check the value of this variable to find the shell you're using. User variable, find your login name. Home variable, find your home directory name. Mail variable, identify the location of your mailbox. Host name variable, the name of your system. The path variable. The path variable is an important variable to know. By default, the path variable contains the following directories: user local bin, the bin directory, user bin directory. So any executable residing in the directories mentioned by the path variable can be executed from anywhere on that system. We continue with the path variable. You can append any directory of your choice in the path variable using the setenv command. However, the norm is to use the set command to add another directory or set of directories and put it in the users.chrc file. We continue with the path variable. It is best to practice using the set command to edit your path variable. The set syntax differs from setenv, so make sure that you practice it. In this example, we are adding two new directories to the existing path using the set command. Thank you, and let us go over to the demo.
Hello folks, in this demo we are going to talk about the path variable and the which command. The shell looks at the value of the path variable to execute programs from any directory on your system. Let us first look at the value of the path variable. We see 5 directories: user lib64qt 3.3 bin, user local bin, user bin, user local sbin, and user sbin. What do they mean? When you enter a command in the shell prompt, the shell looks at the value of the path variable to search the directories the executable has come from. For instance, the pwd command gives you the present working directory. But when you enter the command which pwd, this gives you the absolute path to the executable pwd, and the directory /user/bin is in the path variable, and that's the reason why the shell got pwd executed correctly from another directory. We also have an executable called hello world.csh in the home/Sujata directory. We can also run hello world.csh from anywhere on the system if we add its directory /home/Sujata in the path variable. Let us look at the content of hello world. It just echoes back hello world. In the next demo, we will learn to modify the path variable. Thank you. Hello, in this demo we will learn to modify the path variable by appending a new directory /home/Sujata to it. The purpose is to let the shell find an executable called hello world.csh in the directory /home/Sujata, and to let this file to be able to execute from anywhere on the system. To modify the path variable, we use the set command. Let us now check the value of the path variable. We see that the directory home Sujata has been added. Now, since we are in the /home/Sujata directory, which is where hello world.csh is in, why don't we change the directory and see if we can run hello world.csh from another directory? This will conclusively prove that path variable is indeed working. So let us go to the directory dir1. There is nothing inside dir1, and we should be able to run the file hello world.csh. Yes, we are. It is working. Our modification of the path variable is successful. Thank you for watching this video. Welcome to Demo 2. Let us look at some other environment variables. The shell variable. I have been in the level 3 technical support for many years. I often do multiple desktop sharing sessions with my customers, and I always check the value of the shell variable to know which shell they are working on. Echo shell. So right now we are on the C shell. Along with this variable, have a look at the shells file in the etc directory. This gives you the list of shells available on your system. If need be, you can install the missing shell. For instance, I don't see the conch shell here. The home variable. Many applications use this variable to keep their users' files in. The hostname variable. There is a variable as well as a command that should give you the same result. Echo hostname and the command. And that's all we have in this demo. Thank you for your time.
Hello folks, welcome to the quiz. Question number 1. To find the name of your host name, which is the correct command? Your options are A. Hostname, B. Echo $hostname, C. Echo $hostname in capitals, D. Hosts. Question number 2. To identify the shell, which command will you use? Your options are A. Echo shell in capitals, B. Echo shell in small letters, C. Echo $shell in capitals, D. Echo shells in small letters. Question number 3. The responses outputs of echo $user and who am I are same. Is it true or false? Answers. Thank you. Hello and welcome to the section Advanced Take on Shell Fundamentals Part 2. In this section, we discuss the following topics: the alias command, the echo command, the exit command. The alias command. Type alias on your command prompt and you will see two columns. For example, if you type ll, ls-l will be executed. Consider it as a Windows shortcut. We continue with the alias command. You can also assign an alias using the alias command and put it in the .chrc file so that it can be available on all the shell. The syntax of the alias command is alias space designation space meaning. The echo command. In Linux, everything is a file. So when the echo command is followed by a variable or a string, it creates a file on the standard output, that is, your monitor. We continue with the echo command. Some options that are provided with the echo command. Use /b character code for backspace. This eliminates the space between two strings. We continue with the echo command. The -n flag when used eliminates the new line. Check the difference when you did not use -n and when you used it. We continue with the echo command. The /t character code adds a tab between two strings, as you can see here. Let us study the exit command, which is used in shell scripting and in system administration. The exit status determines if the preceding command has been successful or not. If you try to list a non-existing file with ls, for example, ls space prathim, you get an error message. ls cannot access prathim, no such file or directory. Now, to check if the command is successful, obviously not, check the values of special variable, $question, or $status. Anything other than zero exit status is an error. In this case, it is 2. We continue with the exit command. But what does 2 mean? For that, do man ls. Man is a command to seek information about other Linux commands. Search for exit status and you see that it means 2 if serious trouble cannot access command line argument. Of course, we know that the file pratim simply does not exist. Now let us go over to the demo.
In this demo, we are going to talk about the exit command. The exit command is extensively used in shell scripting to return the status of a script or a piece of code. The status should be 0 for a successful run and non-zero for an unsuccessful run. Let us run the ls-l command on a non-existing file. Obviously, we get an error. To see the error status, we check the value of two special variables in the C shell, $? And status. 2. It is a non-zero value, so it is an error. Let us run the ls-l command on a non-existing file again to see the value of the status variable. It has also returned 2. This is also an error status. And that's all for now. Thank you. Hello, welcome to the demo. In this demo, we will learn about the alias command, which is like window shortcuts. Let us run the alias command and understand its output. So the alias of ls-l is ll. The alias of vim, which is the editor, is vi. We can also create an alias. Let us create an alias of pwd command. The name of the alias, let us keep it simple, pwd. Clear the screen, and if we type p, we should get the output of pwd. We do get. Now to make this setting permanent, we can put this in the .cshrc file. Let us save the file, and if we log out and log in again, this setting should be permanent. Hello, we are back. Let us check if p is still an alias of pwd. Yes, it is, because the value is stored in the .cshrc file. Thank you for watching this video.
Hello folks, welcome to the quiz. Question number 1. Is the output correct? Echo -n flag by Mickey Mouse. By Mickey Mouse is the output that you get. Is it correct or not? Question number 2. This is the output of which command? A. ls-l, B. ls-t, C. alias, D. ps-ef. Take your time. Question number 3. What will be the output of the following command? Alias space D space date. Here are your answers. Thank you. Hello and welcome to the section Advanced Take on Shell Fundamentals Part 3. In this section, we discuss the following topics: reading from the command line, positional parameters in C shell. Reading from the command line. When you're creating scripts, you need external stimuli in the form of requests from the command line, unless your requirement is purely automated, requiring no interaction. The variable construct in the C shell used to read from the command line is $sign. See its use in the script. When the script prompts for your name, the value is stored in the variable called name. Then the variable name is used in another piece of the code. Our next topic is positional parameters in the C shell. The positional parameters are derived from the input that we enter. There are 9 positional parameters which are basically buffers, locations in your system's memory. These parameters are like variables used to make your C shell script more reusable. We continue with positional parameters in the C shell. Look at the following script second.csh carefully. There are 3 positional parameters $argv1, $argv2 and $argv3. So the entries that you put in the prompt right after the script name correspond to it. The first input becomes the value of the variable $argv1. The second input becomes the value of the variable $argv2. The third input becomes the value of $argv3. The first entry in any C shell script is of course the command interpreter, which translates your scripts to a language that is understood by the computer. The script will simply display the content of the files that correspond to the 3 positional parameters. We continue with positional parameters in the C shell. So we create the 3 files, first.txt, second.txt and third.txt, and use the script to display the content of the 3 files. Thank you, and let us go over to the demo.
Hello and welcome to the demo. In this demo, we are going to talk about the positional parameters in the C shell. There are 9 positional parameters in the C shell ranging from $argv1 to $argv9. They are nothing but variables that assume the value of entries that you put after the script name. Let us create a small script, fruit.csh, to understand positional parameters better. vi fruits.csh. Let us take the color out. Send off. Insert mode, starting with the command interpreter. Echo the name of the first fruit is $argv bracket 1 close. Echo the name of the second fruit is $argv square brackets 2 close. Save the file. Okay, let us give it executable permission. chmod +x fruits. Okay, clear the screen, and we are going to run the script from the current directory using /fruits. Let us put the name of the first fruit as apple and banana, second fruit, and let us press enter. Okay, so we get this output. The name of the first fruit is apple, the name of the second fruit is banana. So the substitution is working. Many times you need to provide the name of the script. This cannot be done with positional parameters, but you need to use another construct called $0. Let us use it in the same script. vi fruits, open file, go to the insert mode, echo the name of this The name of the script is $0. Save the file, clear the screen, apple, banana. Okay, now we get the name of the script as well. Here it is. Hello. In this demo, we will learn about reading from the command line using a special construct $sign. Let us create a small script. vi csh. Insert mode. Let us add the command interpreter. Hash exclamation /bin /csh. Echo. Please enter your age. Set age variable to the special construct $sign. Echo. My age is $age. Save the file. Grant the file executable permission. Run the file from the current directory. Please enter age 18. That's it. This is the way you read from the command line. Thank you.
Hello folks, welcome to the quiz. Question number 1. What will be the output of the following command? Set age is equal to 48, echo space age. Your options are A, blank, B, age, C, 48. Question number 2. What will be the output of the following series of commands? Set space mountain $less than, echo space $mountain with M being the capital letter. Your options are blank, undefined variable, hello, mountain. Question number 3. Variables are to memory as files are to hard disks. Is this a true statement? Yes or no? Here are your answers. Thank you. Welcome to the new section, Operators and their types. In this section, we discuss the following topics: arithmetical operators, relational operators, file testing operators, logical operators. Arithmetical operators, addition, subtraction, multiplication, division are operators that enable mathematical calculations. Arithmetical operators in the C shell are plus, used to calculate a value that is the sum of two numbers, minus, used to calculate a value that deducts the second number from the first, star, multiplication of two numbers, slash, division, plus plus, incremental value adds 1 to the variable, minus minus deducts the value of 1 from the variable, plus assignment operator. Here, please take note of plus plus and minus minus. They are used considerably in looping. We are still in the topic of arithmetical operators. You cannot do mathematical operation by assigning a number to a variable, then using the plus assignment operator to perform addition. This is because numericals are not recognized in the C shell as numbers. This is not Python. They are just considered as strings by the shell. We continue with arithmetical operators. A special command called at is used to perform arithmetical operations in the C shell. The mathematical operator plus equal to is useful as a counter. Consider the following example. In this example, x is assigned a value of 100. The second line has at command followed by plus equal to and 200. This adds 200 to the value of the variable x. So the end result is 300. We are still in the topic of arithmetical operators. What you need to know here is the automatic increment mechanism used in looping. If you set a variable I to 1 and use the at command and plus plus operator, the value of I will increase by 1 until, say, a specific condition is met in the looping script. Relational operators. The relational operators compares two values to meet a condition of either false or true. These operators are a source of great confusion, so you may need to revise this topic several times. The values that these operators act upon are numerical, character strings, and patterns. We continue with relational operators. The operators applicable to numerical values are greater than or equal to, lesser than or equal to, not equal to. We continue with relational operators. The operators that act upon character strings are equal to and not equal to. We continue with relational operators. The operators that act on patterns are $tilde, which means matches the pattern, exclamation mark equal to, which does not match the pattern. We continue with relational operators. These are file testing operators. -e file name, if the file exists, it is true. -r file name, if the file is readable, this is permission related, it is true. -l file name, if the file is a symbolic link, you need to know the command ln for this. -w file name, if the file is writable, it is also permission related. -x file name, if the file is executable, it is also permission related. -z file name, if the file is of 0 byte, then it is true. -s file name, if the file exists and it is greater than 0 in size, it is true. -d file name, if the file is a directory. Remember, in Linux, everything is a file. -f file name, if the file exists and is an ordinary file. -o file name, if the file is owned by the user, then it is true. We continue with relational operators. We have already studied logical operators, so let us just revise. Not, the symbol is exclamation mark. It makes a true value into false. And ampersand requires two input values. The result is true when the two input values are true, otherwise the result is false. Or double pipes requires two input values. The result is false only when the two input values are false, otherwise the result is always true. Thank you, and let us move over to the demo.
Welcome to the demo. In this demo, we will explore the world of operators and its action on files, directories, and permissions. I cannot stress enough the importance of operators. Until you understand the logic of operators, particularly its usage in the real world, it is futile to attempt scripting techniques ahead. We will use the test command to examine the operators. I would suggest that you go through the help of test command using man test. Now let's learn the file testing operator -d. The -d operator checks if the file exists and is a directory. Note, Please remember that everything in the Linux Unix world is a file. We are on the Linux prompt. Let's create a directory called dir1 using the mkdir command. We don't get anything. We don't know if the command has succeeded or not. So let us examine the value of the special operator $? To check the exit status. It is 1. It is an error. The command test-d dir1 has failed. Can you understand what has happened? Of course, I did not create any directory, hence test-d dir1 executed with an error status 1. Watch what happens when I do create the directory dir1. Test-d dir1 echo $? It is 0, so it is a true status. When the command is true, the AND operator works. For example, test-d AND operator echo the directory dir1 exists. So the AND operator works. We learned that the AND operator works because the exit status of first command is 0 or successful or true. Thank you. Welcome to the demo. Let us see what we can do with the -f operator. Creating a file using the cat command and the greater than sign symbol. Yes, cat is a sort of an editor. Cat world hello Oumuamua. Are you an alien? Light sail. Control D to exit and save the file. Check if the file has got created using the ls-l command and the content of the file using cat world. Yes, it is there. Clear the screen. The -f operator checks if the file exists and is a regular file. By regular file, we mean that it is not a character, symbolic link, or block device file. Test -f world AND operator echo. Yeah, the file exists. The OR operator oops, the file is not there. Okay, we get this output. Because the file world exists, the AND operator command has got executed. Let us delete the file and let the OR operator come into action. rm world. Clear the screen. Let us run the command. As you can see, after deleting the file, the OR operator has come into play. Thank you. Hello. We now take up another example using the -e operator. It just checks the existence of the file in your hard disk and does not care whether the file is a regular, character, or a block file. Consider a scenario that an application leaves a log file in the home directory of the users. But some settings need to be updated by your IT department and a variable is required to be set in the environment of the users, but only if the log file exists. If the log file does not exist, the variable is not set. Create a hidden file called .extra. Note, hidden files can be seen using the ls-a command. .extra ls-. The file exists. Now for the test expression, clear the screen. Test -e ~/.extra. The AND operator, set env http at 10.10 1.1.1. OR operator, nothing to be done. Test -e ~/.extra checks if the file .extra exists in the home directory. In this case, it does. It returns 0 exit status, which enables the AND operator to execute, which in turn sets the variable http. We examine the value of http variable. The correct value is set. Let us delete the file .extra and see what happens. Since now .extra does not exist, the OR operator takes over and executes its code. Clear the screen, run the test expression again. Nothing to be done. It is important to check the two logic states, true and false, while creating scripts. The tilde signifies your home directory. You may just use cd tilde to get back to your home directory from anywhere on the system. To summarize, here we have learned practical application of the -e operator. Thank you. Hello. We now take up another example using the -e operator. It just checks the existence of the file in your hard disk and does not care whether the file is a regular, character or a block file. Consider a scenario that an application leaves a log file in the home directory of the users. But some settings need to be updated by your IT department and a variable is required to be set in the environment of the users, but only if the log file exists. If the log file does not exist, the variable is not set. Create a hidden file called .extra. Note, hidden files can be seen using the ls-a command. .extra ls-. The file exists. Now for the test expression, clear the screen. Test -e ~/.extra. The AND operator, set env http at 10.10 1.1.1. OR operator, nothing to be done. Test -e ~/.extra checks if the file .extra exists in the home directory. In this case, it does. It returns 0 exit status, which enables the AND operator to execute, which in turn sets the variable http. we examine the value of HTTP variable. The correct value is set. Let us delete the file .extra and see what happens. Since now .extra does not exist, the OR operator takes over and executes its code. Clear the screen, run the test expression again. Nothing to be done. It is important to check the two logic states, true and false, while creating scripts. The tilde signifies your home directory. You may just use cd tilde to get back to your home directory from anywhere on the system. To summarize, here we have learned practical application of the -e operator. Thank you. Hello, welcome to the demo. I want to talk about the NOT operator, which makes a false statement true or vice versa. We create an ordinary file without execute permission. Note, the permissions of your files and directories depend on a command called umask, which is set by your system administrator. The permissions you inherit when you create a file or a directory is because of the umask command. Now let us go back to the subject. Let us create a file called foo using the touch command. Check if it has execute permission. It has no execute permission. The operator to check if a file has execute permission is -x. Now for the code. Test -x foo and operator echo true or operator echo false. It is not as easy as it looks. What will be the response? Let us try and find out. The response is false. What happened? When tested the file foo, it found that it had no execute permission. Hence its error status is non-zero. But the AND operation is only successful if the first command returns 0. Hence the AND operator failed. And the OR operator worked because it works on failure or an exit status of non-zero. Now to make test -x foo true, we should use the NOT operator symbolized by the exclamation mark. But let us start from the beginning. Test -x foo. Check the error status. Echo $question. It is 1. Hence the OR operator worked earlier. Using the NOT operator now. Test exclamation -x foo. Now it should be read like test if foo does not have the execute permission. This is a true statement. Let us check the error status. Echo $question mark. It is 0. Thus the AND operator must work now. Let us use it in the main code. Putting the NOT operator here, and we should see true. And we see true. The AND operator works. Thank you so much. Hello. We now take up another example using the -e operator. It just checks the existence of the file in your hard disk and does not care whether the file is a regular, character or a block file. Consider a scenario that an application leaves a log file in the home directory of the users. But some settings need to be updated by your IT department and a variable is required to be set in the environment of the users, but only if the log file exists. If the log file does not exist, the variable is not set. Create a hidden file called .extra. Note, hidden files can be seen using the ls-a command. Dot extra ls minus. The file exists. Now for the test expression, clear the screen. Test minus e tilde slash dot extra. The AND operator, set env http 80 at 10.10 1.1.1. OR operator, nothing to be done. Test minus e tilde slash dot extra checks if the file dot extra exists in the home directory. In this case it does. It returns 0 exist status, which enables the AND operator to execute, which in turn sets the variable HTTP. We examine the value of HTTP variable. The correct value is set. Let us delete the file .extra and see what happens. Since now .extra does not exist, the OR operator takes over and executes its code. Clear the screen, run the test expression again. Nothing to be done. It is important to check the two logic states, true and false, while creating scripts. The tilde signifies your home directory. You may just use cd tilde to get back to your home directory from anywhere on the system. To summarize, here we have learned practical application of the -e operator. Thank you. Hello, welcome to the demo. In this demo, we learn to work with integers. I have updated the operator table used with integers because the symbols of operators do not work consistently in various implementations of the C shell. Instead, it is better to use the operators which are shown in the table below. An example we can start with is test if 54 is greater than 64 and operator echo true or operator echo false. Can you guess what will happen? False. The test command is testing if 54 is greater than 64, which is false. Hence the exit status is non-zero and the OR operator command has got executed.
Hello folks, welcome to the quiz. Question number 1. The value of x is set x is equal to 59 @ x space minus equal to 69. Your options are A 10, B 128, C -10, D -128. Take your time. Question number 2. Equal to is used with which strings? Your options are A character or numerical. Question number 3. The statement is valid for if the file is executable, it is true. If not, it is false. Your options are -r, -i, -w, -x. Here are your answers. Thank you. Welcome to the new section, beginning C Shell Scripting Part 1. I have a request. Please learn the operators by heart before you start the current section. Please use if-then-else decision making with all the operators. Create simple scripts, but do create them. And with time, you can conquer any scripting language. If-then-else. This is a decision-making flow that generally deals with two sets of data and accordingly decides the logic state of true, 0, or false, non-zero, and then each would have its own set of outputs. In the following syntax, two expressions are evaluated and depending on their state, 0 or non-zero, different set of commands are executed. A very simple example will be if the value is true, then execute the following commands and endif, end of the script. Consider the script 1.sh. We are using the positional parameter argv1, which means the script expects a file name after the script name. The -r operator checks if the file is readable. If the file is readable, then the code echo argv1 readable is executed. If the file is not readable, then the code echo the file argv1 is not readable is displayed on the monitor. Now consider the script 2.sh. Again, there is usage of positional parameter and also pattern matching operator equal to tilde. The script expects that you type hello after the script name. Then only it will proceed to execute the code echo, this is how you greet people. If you type something other than hello, the code echo, you are wrong is executed. Let us look at another example. There's a Linux command called arch. The command instantly tells you if your system is 64-bit or 32-bit. You need to know this information because 64-bit applications will not run on 32-bit Linux boxes. The output of the arch command is the value of the variable CPU. The value is pattern matched to x86_64. And if there is a match, you see this is a 64-bit machine. If the value of CPU variable is other than x86_64, the statement this is a 32-bit machine is displayed. Thank you, and let's move over to the demo.
Hello, welcome to the if-then-else decision-making demo. Let us test if a file is readable or not using the if-then-else structure. Create a file called readfoo.txt using the touch command. Remove the read permission from readfoo.txt using the following command and again check with ls-l. chmod -r removes the read permission, readfoo. Next ls-l. We don't have any read permission anywhere. Let us then create the script. vi1.csh. Take the color off. Insert mode, command interpreter. If -r operator, this is the operator, $argv1, then echo $argv1 is readable. Else echo argv1 is not readable. And if the argv1 is a positional parameter that reads the first input after the script name. In this case, it will be readfoo.txt. To run the script, let us make it executable. First, let us save the script. Give it executable permission. Clear the screen. To run the script, you should get the expected result that the file readfoo.txt has no read permission. So let us run it against the script. .1.csh readfoo. Yes, we have got the expected result. Now let us grant the file readfoo.txt read permission using the chmod plus R command. Chmod plus R readfoo. Let us check. Yeah, so we have the read permission here. And run the script again. 1 readfoo. Of course, we should get readfoo.txt is readable. This is how you test scripts. In software companies, product validation folks do this kind of a job. Thank you so much. Hello, welcome to the demo. Let us look at another example of if-then-else decision-making structure. vi2.csh. Let us take the color off. Insert mode, command interpreter. If $argv bracket is pattern matched equal to tilde to hello, then echo this is how you greet people, else echo you're wrong. End if. The positional parameter argv1 matches the pattern hello and will return true only if you type hello right after the script name on the command prompt. If you type anything else, it is deemed false and the else statement comes into play and executes the code you are wrong. Let's see it in action. Save the file, clear the screen, give it execute permission, x2. Now run the script from the current directory to hello. This is how you greet people. So it is correct. Let us type something else. Instead of hello, let us type bye. You're wrong. Thank you. Hello, welcome to the demo. We are going to use the arc command in the if-then-else scripting. Arc. The output is x86_64. You can also use the command uname-m to get the same output. These commands are used to determine the architecture of your machine, whether it is 32-bit machine or 64-bit machine. Now automate it using the script 3.csh. Clear the screen. vi3.csh. Take the color off. Insert mode, command interpreter. set CPU equal to backtick arch backtick. That's how you turn outputs of Linux commands into a variable's value using backticks. If $CPU is pattern matched equal to tilde x86 underscore 64, then echo this is a 64-bit machine, else echo this is a 32-bit machine, and if the output of the Linux command arch is a value for the variable CPU. The output of arch is either x underscore 64 or I686 for 32-bit machines. So you don't have to do any text manipulation. The output is pattern matched inside the script itself to x86 underscore 64, and if true, prints the echo statement on the standard output. This is the echo statement. Let us save the file, give execute permission, run the script from the current directory. Yes, that's all. Thank you.
Hello folks, welcome to the quiz. Question number 1. Will this script run? Try and copy the script on a live system and try to run it. Note, there has to be a symlink file in existence in the current directory. Your options are no or yes. Question number 2. Will this script execute? ls space l links.sh. Your options are yes or no. Question number 3. Do you require an else statement in an if-then-else script? Your options are no or yes. Here are your answers. Thank you. Welcome to the new section, beginning C Shell Scripting Part 2. You learn about using switch case in scripts. Switch case decision. Decision through pattern matching is the goal of switch case decision scripts. In these kinds of scripts, a string is matched to multiple patterns. The switch statement ensures that the string is tested against each pattern, and if there is a match, a code is executed. If there is no match between the string and the pattern, the switch moves the string to the next pattern to match. If there is a match, the switch will terminate with the end SW command. The pattern is preceded by the case keyword and then ended by a colon. After the colon and in the next line, there would be a command or set of commands. To make provision for the string that is not matching any of the case pattern, there is a default statement. Consider the script 7.csh. Alpha is a variable that is coded to take a value that you input. You're only requested to input 3 letters in lowercase, A or B or C. If you type A, switch matches the variable alpha, that is the value A, with the case statements. The case statement case A is a match. And the code echo, the uppercase is capital A, is printed on the standard output. However, instead of terminating the script at this point, that is, switch should ideally end the script once a match is found, it goes on trying to find matches with other case statements and executing the codes. So another command, break SW, should be used so that other patterns are not checked. Thank you, and let's move over to the demo.
Welcome to the switch case demo. We'll look at a single script to understand the concepts in depth. Let us start looking at the script. The first line is of course the command interpreter. Echo, enter an alphabet between A to C in small letters are the instructions. $alpha is a variable that is coded to take a value that you input. You are only requested to input either of the three letters in lowercase a or b or c. If you type A, switch matches the variable $alpha with the case statements. The case statement case A is a match, and the code, the uppercase is A, is printed on the standard output. However, instead of terminating the script at this point, that is, switch should ideally end the script once a match is found, it goes on trying to find matches with the other case statements and executing their codes. This is undesirable. Check how, depending upon the letter you enter, the output varies. When you enter A, the codes analogous to case B, case C, and default are executed. The default statement is a trash can of sorts, where inputs that do not make any sense to the script are dumped. Welcome to the part 2 of the demo. Let us try and run the script. When you enter A, the output is where all the codes are executed. As you go down the script, the number of codes that get executed get progressively smaller. Let us try inputting B. In this case, the case A switch is not executed. B. Let us try inputting C. Let us try some other alphabet for which there is no match, like E. Clear the screen. Because of this undesirable behavior, you must use the command break SW. When a match is found, break SW gets the script to exit. Welcome to part 3 of the demo. Let us see what happens after you add break SW command to the script. Let us open the file again. Insert mode. Add the break SW command here. Here. And in the default statement as well. Let us save the file and try and run the script. Let us see what happens when you enter A. This is what we want. Let us see what happens when we enter B. Yes, this is the kind of behavior we are looking for. Thank you.
Welcome to the new section beginning C Shell Scripting Part 3. Here we learn about looping. Looping in C shell scripting. Looping refers to a programming concept in which an action is repeated till a condition is true. When the same condition becomes false, the loop is terminated. Another word for looping is iteration. The C shell has two looping mechanisms, while and for each. Looping in C shell scripting while. In the while loop, the looping keeps on repeating until the condition is true. When the condition becomes false, the loop terminates. The premise must be that the condition must hold true in the beginning till the looping makes the conditions fall. The syntax of while loop is easier than in the bash scripting. An example of while looping. Consider the script 11.csh. Pay attention to the statement $i is greater than equal to 10. We know that the value of I equals 20. So the while loop will continue iterating till $i greater than 10 becomes false. It will only become false when I equals 9. Then the loop terminates. So the script will loop 11 times to get to 9 and terminate the script. Look at the decrement counter -1, which decreases the value of I by 1 in each loop. The for each loop. The for each looping is a popular iteration technique and is often used in the prompt itself. It consists of list of items, be it numerical, strings, or even files. The looping depends on the number of items in the list. An example of for each looping. Consider the script 14.csh. X is a variable that will take up the values in the list and run 5 times because 5 fruits are in the list. Thank you, and let's move over to the demo.
Hello. Looping is a computer program that keeps on running until a condition becomes false. Looping takes place using while and for each in the C shell. Let us examine while looping in this demo with a small script. Let us call the script 20.csh. vi 20.csh. Let us take the color off, send off, insert mode, command interpreter, hash, exclamation, /bin csh. The value of x variable is 10. Set x is equal to 10. Now for the most important part, the condition. While $x is less than or equal to 20, echo $x, which means the condition is true till x becomes 21. When x becomes 21, the condition becomes false and the loop terminates. To help it become 21, we add the increment counter at x++ and end the script with end. Let us give the execute permission to the script. chmod plus x 20. Fine. Let us run the script from the current directory. 20. It's a bit too fast, but we can see that the loop is terminated as soon as it reached 21. So let us take it in slow motion by adding the command sleep1, which means that it will wait for 1 second and run the script. vi 20.csh. go to the insert mode, add the sleep command and let it sleep for 1 second. Save the file, clear the screen, let us run it again. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So, as soon as it reached 21, the loop has terminated. Thank you for watching this video. Hello folks, welcome to the demo. For each looping is easier than while looping because the looping is dependent on the items in the list. If there are 10 items in the list, the script will run for 10 times and terminate on its own. Let us create a small script and see for each looping in action. vi art.csh, take the color off, insert mode, command interpreter, for each I, where I will assume the value of the element in the list. Let's put some odd numbers, 1, 3, 5, 7 in the list. 1, 3, 5, 7. Echo $I as it assumes the value of each element, and end the script. Let us add execute permission to the script. Clear the screen, run the script. It is too fast. Let us add the sleep command for 1 second and see it in slow motion. Insert, add the sleep command, sleep 1. Save the file, clear the screen and run it again. 1, 3, 5, 7. And that's all. Thank you for watching the video.
Welcome to the section Beginning C Shell Scripting Part 4. In this section, you learn about break and continue commands. Break and continue commands. The break and continue are inbuilt commands used in while and for each loops. Break is used to exit from the loop, while continue returns the control to the condition statement. We will use a single script to demonstrate the behavior of break and continue using for each loops list, which has 5 elements: Mars, Saturn, Pluto, Ganymede, and Jupiter. Since Ganymede is a satellite, it is the odd one out of the planets and will be used to demonstrate the break and continue commands. Break command. In the script 18.csh, the variable x should loop as per the items in the list, which are Mars, Saturn, Pluto, Ganymede, Jupiter. But we have a if-then statement where if x matches Ganymede, it encounters the break command, which terminates the script and Jupiter is not displayed. Note the echo $x statement. Continue command. When continue is used in the same script, the control goes back to the for each expression, allowing the display of the 5th element in the list, that is Jupiter. Note the difference. If break was used, the script will terminate at Ganymede. But due to continue, the script will keep on running till it encounters the last element, Jupiter, which will be displayed due to the echo $x statement. Thank you, and let's move over to the demo.
Hello and welcome to the demo. In this demo, we will learn about the continue command. This is one of the loop control commands like break. There is another command called goto which is not covered in the course. The continue command causes the script to go back to the test condition while ignoring other commands in the body of the script. Let us create a script called continue.csh. vi continue.csh. Let us take out the color. Insert mode. Start with the command interpreter. for each I, the list now 10, 20, 30, 40, 50. The variable I will assume the value of each entity in the list per iteration. Add the sleep1 command for slow motion. Check the placement of echo statements here because we know that continue will ignore the commands that come after it. Add a condition. If $i equals 30, then echo, hey, you are 30. Then we add the continue command. End this loop. End the script. Save the file. Clear the screen. Let us give execute permission. Let us run the script from the current directory. "10, 20, 30. Hey, you're 30. As soon as I becomes 30 and the shell encounters the continue command, the control is passed to the for each command and not to the end like in the break command. And if the loop is not complete, the iteration continues, and that's why we see the appearance of 40 and 50 on the standard output. Thank you. Hello folks, welcome to the demo. In this demo, we will know more about the break command. The break command is one of the loop control commands like continue. The idea of the break command is to break from the first loop. Let us understand the break command from a script. The break command breaks out of the loop, but not from the script. Let us create a file, break.csh. The color, insert mode, start with the command interpreter. Let us set a variable x to 10. While $x is less than or equal to 15, sleep 1 for slow motion. If $x equal to 12, then echo this first loop terminates with the break command. We'll add the break command here, and if echo $x, add the increment counter at x plus plus. We need this increment counter for the value of x, which is 10, to increase one by one. End. Okay, now this break command here, will, when the script encounters the break command, it will straight away go to end. But it does not mean that it terminates from the script. It actually terminates from the first loop. Okay, let us save the file. Give it execute permission. clear the screen. Let us run it from the current directory. So you see that as soon as x becomes 12, the first loop terminates with the break command. Now please remember, as I said before, the break command breaks out of the loop but not from the script, which means even though break goes to the end command in the script, it keeps on running the script. So how do we see that? Let us go back to the file again. Okay, so after end, we just add a echo command, insert echo, the script is still running. So this should appear after the script, which seems to be ending with the break command. Clear the screen. Let us run the script again. 10, 11. So you see that the script is still running, which means that actions after the end commands are still running with the break command.